with the following is not a solution. I have function y equals to x to the fourth plus 84x to the second plus 243 multiplied by x squared plus 5x minus 36. Did I write correctly everything? So we have a product of two terms in parentheses. This is, do you know how you name this equation? Biquadratic equation, right? Why by quadratic? Because x to the second, just a sec. Let me check whiteboard here, somebody write it. Since this is even powers, so you can make substitution. For instance, x to the fourth equals to t to the second, or x to the second equals to t. I can override this equation. Anybody need this answer, students? Raise your hand. Who need these answers? I need more room. Nobody need answers. Okay, good. So I can override this. It's equals to t to the second plus 84t plus 243 and multiply by this one. Now, since this quadratic equation, I can apply Francois-Vieta theorem and factorize it. T product of two terms equals to 243, and the sum equals to 84. It would be 3 and 81. 3 times 81, 243, and 3 plus 81, 84. Good. Multiply. The second part. The second part. You also can factorize. What is it? Nine and negative 4. After factorization, either t equals to negative 3 or t equals to negative 81 or x equals to negative 9 or x equals to 4. But originally, keep in mind the substitution. It means t equals x to the second. So x to the second equals to negative 3. You can take square root of both parts. Okay. And what is it? Is plus minus square root of 3 times negative 1. It's the same plus minus square root of 3 times square root of -1 or plus minus square root of 3i. So far we have this value. We have this value. We have these values. And what is left? Keep in mind the substitution equal to this. I start from this one. So x, I put here x to the second equals to -81. I make a little bit room here. As you did before, you take square root of both sides. This is x. This is plus minus, which is plus minus square root of 81 times -1, which is plus minus square root of 81 is 9. Square root of -1 is I. And this guy. We have actually how many roots here? We have 2, 4, 5, 6. Now keep in mind what they have in multiple choice. A, which is what is it? -9i. B, negative, what is it? Square root of 3i. Close this radical. C, 3i. And D, 9i. Okay. Do we have 9i? Yes, we have. Here it is. Do you have -9i? Yes, we have this one. Do you have -3 negative square root of 3i? Yes, we have. Do you have 3i? No, we don't. So this will be the answer. Any questions about this, students? Who understand this 100%? 100%. I have seen this question, this kind of question in the test. How to answer this? There's another way you can do this, but this is not smart way. Another way, what you can do? You can plug in each of these and see when it's not equals to 0, but this is not good. Take more time, faster to solve it.
Dr. Farben,
Yes.
can you explain why it's plus or minus?
Plus or minus?
Yes.
For instance, when you have, I give you simple, forget about imaginary part. For instance, you have equation x squared equals to 9. How to solve this equation? I show two different ways. -9 and -9. I'll get x squared -9 equals to 0. After that, I recall, I take different color, I recall the formula, which is a squared minus b squared equals a minus b times a plus b, right? And after factorization, I can represent this like x minus 3 times x plus 3, which is equal to 0. When it's equal to 0? When either x equal to 3 or x equals to -3. So far, so good, Alyssa?
Yes, I understand.
But you can do in one shot. If you take square root of this one, you know the coding the main theorem of algebra, equation of n power has n roots, 2 roots. If I take, I need a little bit more room. If I take square root of both sides, what we're doing? Square root of x squared is x. And always put here plus minus. And you instantly get the same result. Why? Because when you put 3 to the second power is 9, and negative 3 to the second power is 9. Here you get exactly the same analogy what we have here. When you have square root of, what is square root of 9? Who can tell me? Square root of 9. Put your hands down. Who thinks square root of 9 equals to plus minus 3? Raise your hand. How many students think square root of 9 equals to plus minus 3? You understand my question? Square root of 9 equals to plus minus 3. Almost everybody, right? Put your hands down. Who disagree with this? I disagree. This is wrong. Many students make this mistake. Thank you, Alyssa. You're reminding this. Okay, I need a little bit wrong. Look at this. How to check? I will check. Let me bring something. Okay? Just a second. I have collection all calculators starting from previous century. Okay. I don't know, you see this or not? What I got? I got square root of 9 equals to what? Can you see the 3? Not sure. Who can see square root of 9 is 3 here on my screen? It's not 100% clear, small letter, but square root of 9, 3. Never plus minus, never. Look at this. Square root of 9, always 3. Absolutely wrong if you write plus minus 3. No way, no way. But when you have x squared equals to 9, and you take square root when you have these variables and get x, and this must be plus minus, it would be plus minus 3. Why? It's not because of square root of 9 is plus minus 3, not at all. Square root of 9 is 3, but because of this guy. According to my theorem of algebra, we have to have not 1 root, 2 roots. And how to check usually this equation? Easy. Take this value, plug in here. Look at this, original equation x squared equals to 9, right? Is 3 to the second equals to 9? Yes, it is. Is negative 3 to the second equals to 9? Yes, it is. So, only when you have equation like this, for instance, use plus minus. Many questions on SAT, they give the same question, and you, oh, so happy. No. Only this way. Who understands this? 100%, 100 forever, and all your life. Who has questions? So again, square root, not because of this square root of this one. No, it's because of this guy. Okay, good, good. Any questions before I raise this one? No questions? Okay. Let me go through another one.
The voltage of an alternating current circuit is given by the formula E equals I times Z, where E is voltage in volts, I is current in amps, and Z is impedance, a type of resistance encountered with alternating current, and OHMS. If a certain circuit has a voltage of 38 plus 18J volts and an impedance of 4 plus 6J OHMS, what is the current in amps that passes through the circuit?
Excellent. Remember last time we discussed that all these electrical devices which use alternate current circuit, they always use what? Complex number. Impossible. If you can't count this electrical chain, you can't build any device. That's why all your devices that you use here, everywhere, they use this approach, complex numbers. Now let's do number 5. What they give you? 5. They give you formula. E equals to I times Z. I is the current. Okay. This is voltage. This is current. And the Z is impedance. You know what is impedance, right? You study basic of physics. If you have just straight, let's say this battery, right? This is battery, and this is resistor. And based on this terminology, this is E, voltage of this battery, and this current goes this way, for instance. And this resistor, active resistor. But when you have alternate current, it could be different ingredients, different components, so like capacitors, and for instance, let's do this way. It could be capacitor and inductor. And to count this case, if this alternate current, right, you must use complex numbers because we have two different ingredients, components, so like capacitor and inductors, not only active resistance. And what is given here? Given, they ask you to find I. Okay, the code is a certain current voltage. This one, what is a current? How to find current? Easy. Divide by square by Z. By Z. I will represent more convenient way. We can write this from this position. I equals to voltage divided by impedance. Now, plug in this value that they give you. Read carefully. What they give you here. This is given, what is it, 38. Voltage is 38 plus 18 I. This is actually I. They use J, but this is I. And what is impedance? Impedance of this is 4 plus 6I. So now forget about this electricity, and we just have simple equation which you can easily solve. Simple complex expression which you easily solve. First of all, you can simplify by 2. It's 2 times 19 plus 9I divided by 2, 2 plus 3I. And I cancel out. This is better. I use the space. You have 19 plus 9i divided by 2 plus 3i. Remember, main conditions, we cannot have in the denominator complex number. We multiply by conjugate. So I take different color and I want to get rid of this in the denominator. I multiply this by conjugate 2 minus 3i and 2 minus 3i. Okay. I put in parentheses this. Now it's just product two binomials, keeping my property of complex numbers. Multiply by 19 everything. You will have what? 28, 38 plus minus 57i. I multiply 19 times 3i plus 18i and minus 27i squared. This is numerator. So far so good. Denominator 4 minus 9i squared. Keep in mind this, guys, equals to -1. Okay, I continue with it. Actually, if this is -1, it's like plus 9 plus 4. This is 13. 13. I just want to save space. It's not too much space. And this is -1. This -27. It becomes plus 27. Now combine like terms. Right? What we have? 38 plus 27, 65. Minus 57i plus 18i. You have -39i. Divide by 13. Now apply butterfly rule. Divide each of these terms. Would be 65 over 13 minus 39 over 13i equals 13 goes into 65 5 times, and 13 goes into 39 3 times. You'll get 5 minus 3i. Okay, they ask you to find this. Only keep in mind here, sometimes they use I, sometimes electrotechnically study, instead of I, they use J. But when they use J, you see at the beginning, they emphasize the J equals to square root of -1. Practically, it's not, it's I. Okay. Why using electricity they use J? Because in very often cases, current use I. In order to avoid the ambiguity, right? Because I is current and I is this imaginary part. So I explained all these parts. If I step back, if you have any question, ask me. No questions, good. Now go to the next part. So keep in mind, we did with you to find pattern. For instance, I, or I to the first is I to the second equals to -1 by definition. I to the third equals I to the second times I. Since I to the second is -1, times I equals to negative I. And finally, I to the fourth equals to I to the second, which is negative 1 to the second, which is 1. And we have this relationship. I, negative 1, negative I, 1. And it keep going. This pattern not necessary to memorize. You can easily, when you have this problem, you can restore in your brain. And what is good, any number which are multiple of 4 in power this one, give you 1. So I can represent this 14. What is 14? Let me write here, for instance, 14 is 4 times 3 plus 2. So far, so good. This is 122. 122. Yes, 122. 122 equals 4 times 30 plus 2. I always want to find out how many multiples of 4 we have in these numbers. So based on this, I can override this. It's the same, like I need a lot more room. I to power of 4 times 3 plus 2 plus I to power of 4 times 30 plus 2. I do it deliberately step by step because. And what is it? It's the same like I to power 4 times 3 times I to power 2 plus, because you know this rule, a to power m times a to power n equals a to power m plus n plus I to power 4 times 13 multiplied by I to power 2. Now I use another formula. A to power m to power n equals a to power mn. mn. I can write this one. It's the same like I to power 4 to power 3 times I to power 2 plus I to power 4 to power 30 multiplied by I to power 2.
He brought his girlfriend with him. I was not rude to her, but she was really hostile to me.
The same question they asked over and over, nothing new in this SAT. I have SAT from 1924. I bought an auction. It's even more challenging right now. Okay, but look at this, what they accomplish. I to power 4 is 1. Instead of this guy, I can write right here. It's the same like 1 to power 3. I to power 2 is equal to negative 1. I to power 4 is 1 to power 30. I to power 2 equals to negative 1. 1 to power 3 is 1. 1 times negative 1 is negative 1. 1 to power 30 is 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 equals to negative 2. I deliberately explain in very, very details this one. If you understand this, you solve any problem related to this kind of this. I believe this is the best representation of the steps. Probably you will not find in both these steps. this so in details, you know that you do a few times, you'll be expert. Who understand 100% of this? 100. Islam, Theodore, Islam, you with me? Parvina, Theodore, Parvina, you with me? Dimitra? Can you raise hand when I ask you 2 seconds? In this case, I will understand that you careful enough. Put the hands down. Okay. Tune, this is a real question from real test. Just different numbers. Few students asked number 10. In number 9, 5 for power 416. Like we did before, I will use this space for 60. Since we have a loop of every 4 items over and over again, like we did today, I divide it by 4. And what I'll get? This is 1, 4. Bring down 6. 4 goes into 6 one time. 1 times 1, 1 times 4 is 4. 21, 15. And the remainder is 0. You can represent that for 60 equals the same like 4 times 1, 15. Right? Plus 0. The remainder is 0. So I can represent this like I to power 4 times 115 plus 0. Or based on rules what we had here, rule for this one, for product, and for power, for exponent, I can write this the same I to power 4 to power 115 multiplied by I to power 0. I to power 4 is 1 equals to 1 to power 115. Multiply I to power 0. I to power 0 is 1. Any value to power 0 is 1. And they ask you to find what in this case? They ask you to find the value of this, right? Simplify. So it's the same like 1 to power 115 times 1, which is 1. Classical example, and we did in very details this one. Who understand up to this point everything, students? Good. And finally, this was Parina question.